Simon Davis, and I'm the engineering manager for the Terraform AWS provider. I've been in this position for about 2.5 years, and in that time I've seen HashiCorp and AWS grow strong relationships across many service teams. In fact, each week my team will meet with 2 or 3 different AWS service teams, and we talk about new and upcoming features, we talk about coverage gaps in existing functionality, and in some cases we talk about workflow issues that our mutual customers are having. But what I didn't really expect when starting this role was that of those service teams, the cloud formation team would actually be the team where we had the strongest relationship. And why not? Like, we're both trying to solve the same problem. We're both trying to give infrastructure code practitioners the best experience while trying to control and leverage AWS services. And here with me from that team is Ben Perak, who's head of infrastructure as code at AWS.
Awesome. Thanks, Simon. Yeah, I just want to echo what you said. So super excited to be here. Super excited about the partnership we have. It's an interesting dynamic when you lead a product, and arguably in the industry, people see us as competitors, but I see them as one of our most valuable partners. So definitely appreciate the opportunity to be here. So Ben Perak, I've been at AWS about 5.5 years. It's kind of funny, that picture was my first day. You can see changed quite a bit. Came with my blazer, now we're wearing t-shirts. I currently head the product for all of AWS IC. So that includes, as Simon mentioned, CloudFormation, includes CDK, it includes what I'm excited to talk about today, Cloud Control API, and a few other things. So we'll go through quickly the history. Want you all to understand why we're here and kind of what Simon mentioned. What are the problems we're trying to solve? We'll go through what Cloud Control API is. That's kind of our contract to this whole partner engagement. What does AWS have to provide for this? And of course, Simon will come in and talk about the actual Terraform Cloud Control provider, get real deep in what that means. That's the Hashi side of this partnership to make this whole solution work. And then we'll talk a little bit about what's going on and where we're going with this. So where the journey began. So rewind about, I guess, 3 years ago, we were at reInvent 2019, the last big one. And we got together as a team, and we started just to have the collaboration around, hey, what do you see in the market? What do we see in the market? What do our customers need? And through that conversation, we started to realize we have the same problems. We're trying to solve the same problems. They're trying to solve the same problems. We have the same customers. And it really dawned on us, like, why are we going at this alone? Why don't we try to come together and solve this as true partnerships? And so from there, we got together, and Simon will go through a little bit more details of the evolution of the partnership. But that's really where this whole thing started. It triggered us to do a lot more innovation around our portfolio and how we solve these problems. And I think we came up with a really good solution here. So through those conversations, we started to look and see what are the opportunities we have. So the first opportunity was obviously access to the latest AWS innovation faster. The number one thing we hear from customers is, if it's not an IAC, I can't use it. People manage their infrastructure using infrastructure as code. And so providing them access to those services faster was a key challenge. We've dealt with it. The Terraform provider had dealt with it. So we set off and said, how do we solve this opportunity of, new AWS features and services be supported closer to launch? Not even closer to launch. Why don't we just really make it happen so we make it at launch? Well, that was the first opportunity. Second opportunity was automatic support for new AWS capabilities. So as we were talking, we said, it's hard to build these resources. It's hard to have coverage. It's expensive. We have a lot of different AWS service teams. Simon mentioned he meets with them regularly. We meet with them regularly. reInvent coming up. You all are maybe excited for these different conferences and launches. We're scampering, running around, trying to figure out, do we have the right people to build and provide support and coverage? We thought through this and said, we got to make an easier way to solve this problem. We have to automate this away. We can't keep trying to just build this and spend resources trying to provide coverage. We have lots of innovation, obviously 200 plus features, lots of new features coming out, or 200 plus services, lots of new features coming out. Trying to keep up with that through manually building out these resources was too hard. So the second opportunity we saw was, how can we automate support for new AWS capabilities? Automate being the key word. The next was, and you all may know this if you're using AWS a lot, is every AWS service has its own control plane, own set of APIs. And when we're trying to automate something against a whole bunch of different APIs, that becomes pretty difficult. And so we said, we need a better way of having a single API a single way of being able to integrate and communicate with these different services. And so we said, well, is there a way that, or how can I use a consistent API method to interact with these hundreds of AWS services? That's the first challenge if we're actually going to try to solve anything with automation. So those are the top 3 challenges or opportunities that we all looked at and said, we got to solve this. And so we went away and we did a bunch of work. As Simon likes to say, we went dark for 9 months. And I said, well, we're in a dark room trying to solve this problem. And we came out and we had a solution. And the solution was, Cloud Control API. So Cloud Control API is a common set of control plane API on top of our resource model. It provides you one consistent method to be able to say, I want to create an S3 bucket. Well, you don't need to know what the underlying service APIs are for that. You just go to Cloud Control API, you say create, you give it a resource, it's going to go and create it. You want to create a second resource, you go and say create AWS : S3 bucket, it's going to go and create it. So now you have one consistent set of create, read, update, delete, list handlers with one common resource specification to support that. Pretty powerful, I think. If you really think through, like, is this the next generation of the AWS API? I like to think so. So how can it benefit users? Well, first opportunity was faster access to new AWS services. Is that solved through Cloud Control API? Not technically. That's a different challenge. And so what my team went back and said is, we need to figure out how to scale this whole model of resource coverage. It's a process problem, not a technical problem. So we went, got a lot of support from leadership. We demonstrated the power of IAC, why it's so important to manage these services. And we implemented a mandate across AWS that says you can't launch a new service or feature unless you have support for infrastructure as code. Just like you need support for SDKs, you need support for infrastructure as code. So that's a key piece here. Service teams, when they're launching a new service, they have to have resource coverage support. That's the process piece. We also implemented a standard model for how you define that resource. So standard specifications, standard set of CRUD API handlers. And that allowed us to say, we're launching a new service. It has to have IAC support. That support is built using the standard model, and that model is exposed to Cloud Control API. So we solved that first problem. The second problem is we needed this unified interface for automatically exposing these things, and that is what Cloud Control API provides. We now have this one single way of having to build, which allows Hashi and Terraform providers to actually build that automation. So we launch something that has a standard specification, their automation kicks in, and they pick it up. So we solved the second problem of the time and effort it takes to build resources by driving more automation. And then the third one, of course, is we have this standard way of actually interfacing with AWS services. It's pretty powerful. And so now, like I mentioned, if something comes out, and there's lots of partners that are looking to solve this problem. You know, obviously we're here, we're talking about more of an infrastructure as code, but there's a lot of partners like inventory management partners. And these partners are saying every time a new service comes out, I need to be able to understand what the read handler looks like or the get API so that I can pull in what the resources are, the properties of these resources. Well, now they know they can just come to Cloud Control API and they have one consistent way of saying read. No longer do you have to go and get all the details of a specific set of operations. You just go to Cloud Control API. So we really provided and addressed those 3 opportunities and provided these different user benefits. So how does it work? So as I mentioned, each service has their own set of control plane APIs. A resource is nothing more than an abstraction. It interprets what's in your template, and it calls those underlying APIs. But we needed to make sure that that resource had a standard definition, a standard schema. So we created a standard schema. That allowed us to then say, every resource, same shape, same model, same set of cardinal operations. Which is great because now we can go ahead and slap on, this nice little, got a formatting issue here, nice set of APIs on top of all those resources. So we start with a resource model, we drive to consistency, we drive one common API control plane on top of that, and voila, we have the magic of Cloud Control API. So if we look at a little bit more detail, what do we mean by a standard resource? What do we mean by a schema? We'll get just a little details here. This is what a schema looks like. It has lots of different things, the name, the description. It defines all the properties of that particular resource. It defines the ID, outputs of what can come from that resource. It has the primary identifier of the resource. It has things like the read-only properties. This is key for when you're trying to do things like references and get attributes, et cetera. It has common handlers. You'll notice here one of the key things that's added here is permissions. It becomes really, really powerful when you want to be able to say, do I have the right permissions to perform these operations? That's all clearly systematically available to you now by harvesting what's in that schema. So it starts to just, again, provide lots and lots of value when we create this one common standard and expose that through this one common set of APIs. So that's where we are. That's our contract. That's what we're providing to this partnership. And we're excited about it. Again, I'll talk a little bit more after Simon's done about where we need to go to expand some coverage items. But ultimately, we're really excited about this. We're really excited to be able to then transition that over to Terraform to be able to create more of the automation. And with that, I'll turn it back to Simon. He'll go through more of the details and kind of get under the hood.
Great, thanks, Ben. So on to the provider. I wanted to start off by talking about some of the early prototyping we did once AWS released some API specifications and schema definitions to us. And that was really, we built a basic prototype and we kind of hit a roadblock pretty much straight away. For those that don't know, most providers are built on the Terraform plugin SDK. And this is kind of the standard SDK that almost all of the providers in the ecosystem currently use. And we hit a bit of a snag here in that one of the things that the CloudFormation schema models is default values. So it'll tell you what a default value is for an operation in some cases. So where we hit a bit of a roadblock is that the SDK didn't really give us a great way to kind of model the difference between where a practitioner has not set a value and where the practitioner has set a value, but it's basically the null value. So it's an empty string or a 0 for an int, etc. So this wasn't something we could get around with the SDK. So our alternatives at that point was the Terraform plugin Go. So this is a lower level abstraction, and this is what the SDK itself is built upon. And providers have certainly been built upon this in the past, but it's very low level, and it requires a whole bunch for us to re-implement. Luckily, the Terraform developer experience team were in early stages of design and development of the Terraform plugin framework. So the plugin framework is essentially a new evolution of the plugin SDK. And the plugin framework is a ground-up rewrite. So this is kind of taking on all the lessons we've learned in growing up this massive ecosystem of providers. So with a little bit of bribery, we were able to get them to agree to kind of shift their development schedule around a bit so that we could write this generated provider in time for Cloud Control's GA. So this was a pretty close thing. So the framework team were pretty much throwing down features and we were picking them up straight away. And week to week, we were kind of working like this leading up to Cloud Control's GA. For those in the room that are aspiring provider developers or existing provider developers, I definitely recommend checking out the plugin framework as it is definitely a step up in usability. So as with the standard provider, every week we try to release a Cloud Control provider. And the first step in this is pulling down all the available resources from the CloudFormation registry. So each week we do typically see some new resources available. And of those resources, in this schema definition, there's an attribute called provisioning type. And what we're looking for here is where they're fully mutable or immutable. This means they're compatible with Cloud Control. Those that are non-provisionable typically will be usable with CloudFormation, but are not yet compatible with Cloud Control. So this API endpoint is regional, so obviously we're hitting US East 1 for the kind of greatest coverage here. So every week we take what's available, we compare it to what we already know about, and we add all the new ones to what's effectively an internal registry in the provider. And this is what the rest of the generation code acts upon. So the generation code will enumerate this list to generate all the resources and data sources. But what this registry does is it allows us to tune the sort of generation behavior at a per resource level. So for an example here, one of the attributes in the CloudFormation schema is available handlers. And so when we're pulling these down, in one case, we're looking for a list handler. If we don't find a list handler, then obviously we cannot generate a plural data source. And so you can see up here, that's an attribute here where we're saying suppress that generation. Another example is where we encounter a schema or something that our code is unable to handle at this point in time. And so rather than stop generation, we just mark that as suppressed and move on with generation for that week and investigate later. So at the time of this talk, there's about 20 resources that we're currently suppressing in this fashion, and that encompasses about 4 actual issues for us to resolve.